All right, so our objective for today, I can solve systems of linear equations by graphing, substitution, and elimination. Now notice that we already know how to do these three, hopefully, most of us. But today we're going to look at something called special systems. There's special situations that you need to remember in regards to systems of equations, okay? We know what systems are. I don't need to revisit that. We already covered definition, examples, non-examples. I gave you guys steps for graphing. We know the steps for graphing. We need to solve for y, graph each equation, and identify the point of intersection of each line. For substitution, we know that we need to solve, substitute, write, and check. For elimination, we already know all those 5 steps. Remember, we also did some signs for it. Change, standard form, eliminate one of the variables, solve for the remaining, substitute into one of the equations and solve, and write a coordinate and check. We know how to do all that. But let's notice, today is about noticing the differences from one system to another. So here's this one. Copy this one down, please. Example 1. Oh, actually, copy this down, sorry. Vocabulary. Consistent and independent. If you want to write these two together, consistent and independent systems are a system with one solution. Consistent and independent systems are systems with one solution. Consistent and independent systems are systems with one solution. Consistent and independent systems, consistent and independent systems are systems with one solution. Inconsistent systems are systems with no solution. Inconsistent systems are systems with no solution. And dependent systems are systems with infinite solutions. Now with red, when you get to inconsistent systems, for this one, I want you to write with red the word parallel. When the equations, once you see them either graph or solve for y in slope-intercept form, and you look at the slopes and they are parallel, that means that there are no solutions. What kind of system is that? Inconsistent system. I'll show you another way of telling that in a little bit. And the last way, dependent system. A system with infinite solutions. This one, in green, you're going to write same equation. When they give you a system where one of the equations already solved for y, let's say the other one is not, but then once you solve for y and you look that it's the same equation, therefore it's going to have infinite solutions. Now let's go to the warm-up really quick. In the warm-up, what did we notice about this? That this one was exactly the same as this one, wasn't it? That's why it's called an identity, and that's why the solutions is all real numbers or infinite solutions. That's why I'm letting you write here where it says when it's the same equations for the system, that's why there's infinite solutions. So once again, consistent and independent, one solution. 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 Inconsistent, no solutions. Inconsistent, no solutions. And the last one, dependent system, is the same equation or infinite solutions. Okay? Let's move on. Copy this one down. Example number 1. Solve y equals x minus 4 and negative x plus y equals 3. Yes. Let's do it together. So here we go. Just by looking at it, do you see that it's very similar to the one we did on the warm-up? Yeah. This one's already solved for y. Everybody see that? Yeah. So therefore, we can use substitution to substitute in here instead of y. What are we going to write? X minus 4. x minus 4. I bring everything else down. The negative x, the plus, the equal, and the 3. All right, so let's continue. Can we combine like terms right there?
No.
Yes, right here. What is x minus x? And we're left with negative 4 equals 3. Is that true?
No.
Therefore, this is no solution. That's it. Let's classify this. If I was to ask you to classify, that means give it a name. Think about it. If it has no solution, what kind of system is it? Inconsistent. Really simple? Yeah, right? All right, so check this out. If I was to go back to the warm-up again, look at this one. Look at this system. Didn't we use substitution? We simplified, solved, and all of a sudden we were able to solve for one variable, didn't we? And then from there we substitute that again over here, the other variable, we got one solution. Is that correct? So what kind of system is this if I was to ask you to classify it? Independent and consistent. Are we there? Okay. So for homework, the only homework I'm going to ask you to do is read into the last portion of the systems, the special systems, and look into, there's one more special system. That's all you're going to look at. Okay? Yeah, of course. And then from there you go to, your homework is on pages what? 353, 354, 1 through 21 odd. Turn in your homework over there. Those of you that have your planner signed, I need you guys over here. Have a good one, everyone. Enjoy your homework. See you guys tomorrow.